This is a split. You can see that it took off completely through the material down the length of it, and that's what we find what the difference is. Let's say if the RH falls below manufacturer recommendation. So the manufacturer may produce, say it's 35% relative humidity, we're going to throw it in a condo. And this condo has no humidification control, so we're going to see somewhere around 20. So we're 15% lower than what the manufacturer recommends. What happens in this here is you'll find shrinkage. And in this shrinkage, it's going to take and start pulling as it wants to shrink. So here you'll find what will happen is the material will finally release and split. I like to use like a rubber band, for example. Wood is it's elastic and it's going to move continuously. Is in the parameters that they give us from the manufacturer, like your 35 to 55%, but if we stretch it, what happens? The band will break. It's the same thing with the face of our wood material. It will break if we take and put it below those type of conditions. So will a thicker wear layer make a difference? You know, that is a real question a lot of guys have asked. But when we start looking at dynamics of material, how many of us, well, there are a few people that are old enough in here. We have the hollow core doors of the 70s and 80s where they were just you could buy them at Menards for 30 bucks in a whole package, but they were a veneer, a red oak veneer, peeled, but they were probably only about a third of the thickness of this paper here, okay? In turn, because that is being on the backer of that core that's there, it's not going to have enough structural strength to actually react to that floor and cause it to split. If we take a 5 mil layer product, it's going to act more like real wood, being glued to a substrate, going in that environmental change, and it will take and go through the stress and it will split. So it's important to know, yes, thinner products will have a tendency to be more forgiving in low relative humidity. The problem is, if we take, I know there's some products that are half mil wear layer on, and some like 1 mil wear layer on, and the first time you move a piece of furniture, it dents because it'll actually compress the core. So a lot of times you get compression in there, whether it's from high heels or sliding furniture, an office chair rolling back and forth, because you don't have enough actual thickness of material here to create the actual density of what the oak or maple or hickory might be. So when you look at the ends and splits, we start going here. As you can see, it's hard in this photograph, but here that's split wide open. There's another one that's split in this photograph wide open, but that's where it's showing the wood is losing moisture either through the ends of the material or the entire material. And when the ends shrink, when the ends dry, they want to shrink, and that'll cause your splitting on the ends. The ends are restricted by the rest of the plank. For example, if it's like you've seen in the other photograph, it's glued to the core, so it's going to take and split in multiple locations on the end, and typically take back about 3 to 4 inches. Now the other is when the wood stresses through, and the splits are a result of an imbalance between the MC of the wood and the EMC of the environment. That's where typically we talked earlier about where the environmental changes are, and the EMC changes in accord with moisture, the equilibrium moisture content of the wood floor itself. And how much? Only 2%. So when we start asking like materials, if they're produced at say 7%, and we're going to push them to 5% on low environmental conditions, you're pressing the envelope of having that rubber band so tight it's ready to snap. This was the original filler in this. This was a character grade material. You can see the filler that the manufacturer used, and under microscope you can actually see where the wood has been torn, where it's been torn after it's been installed. So when we're looking at an inspection like this, if this was at the time of manufacture, we would see wood stain if it was an open check at that point. So if that was a check or a split present at that time, we would see that it would have stain in there. All we have is an filler. So that was a pre-existing condition or character filled by the manufacturer. It was stable at the time of manufacture, stable at the time of installation, and stable most likely for the first 6 months of its life before it ended up going through dry climate and creating it to split like this. And you can see this, and that's when anybody doing inspections, you can typically see, I use a jeweler's loupe, and that one will be able to see if you have any kind of raw wood fibers in there. When the mechanical damage, like here, we can be running a cup plank through a flat machine. When I used to produce my own material, if the plank had a slight cup to it and you're putting the pressure on it to run through the molder on it to put the side match on it, you can put enough torque on it to actually cause that plank to split. If we ended up having, like, we were doing a lot of 12-inch plank at that time, so if you were nailing it down, you could also create enough tension in that cup plank over a couple days to split. If any of us laid Australian cypress, they'd know exactly what happens with, you know, Australian cypress after a few days. You know, plank replacement on the stress. And other ones that'll go into excessive force, you know, when nailing. Yep. And the other common causes is when we start looking at us having, for example, like when we were making our plank, we were doing a lot of long lengths. We were doing lengths from 8 to 12, 14 foot, and you'd be cutting off an end split like you saw in that log. And the end split will go back probably this far. And then the next thing is you cut that off, you're typically 3 inches in, it should be a clean piece of lumber. Well, when that other cause goes in, when we see climatic changes, all of a sudden now that end split that was a latent defect, I couldn't see it at the time of manufacturing it, but it now traveled up, you know, 4 feet into the plank. So there are those conditions where that would be, you know, a defect on a manufacturer side of producing that, and you couldn't see it. This is one where you'll see that materials, we have a latent defect or a split in the material. And as you find the material will go through expansion from excessive moisture, it'll actually want to shear and cause itself to shear vertically upward and cause lippage. Most of the time you will see that this split here is going to be tight. And I think there's another photograph of it. You can see it here, okay? We did one that we did on a hickory floor, and this happened on my job, where we got done laying it, we got done sanding and finishing it, and we had compression checks on this thing probably about 6 months later. Went out to the job site, and I'm looking at that, holy smokes, I mean, there was probably 20, 30 planks looking like this. So we took it apart, and what we actually found was in the hickory, first of all, it was on a radial direction of the material. We also found is the growth rings were tight, 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 and then they had one big good growth of that summer, and then it was tight, tight, tight again. So it was like the sponge of that growth ring was softer, causing that issue to go up in those planks. And so we tried taking a few samples that then I dug into my inventory, went found identical material like that, threw it in the swimming pool for an afternoon, and came out, and you should have seen the shear on that thing because of the way the growth rings were changing direction. Was it my fault or the wood? No, just a characteristic. This gal had an unfinished basement that had, I'm going to say, elevated moisture, no dehumidifiers in the basement. But, you know, that was the first time I ever saw what was called, you know, compression fractures. Another one is we start looking at where we get a knot, where here we have a split in a knot. It's part of the character of that product. But what causes that finish to actually elevate? So if you were going to take, for example, a balloon, and we're going to take a balloon and start blowing on a balloon, what happens then is you're stretching the balloon, correct? It's the same thing when we start looking at vapor pressure from underneath the film finish, and you walk in and go, holy smokes, you're going to see where the film has actually been stretched vertically because the vapor pressure is so strong it cannot release it, and the normal release of that would be in the character of this material, because this is a character grade material, and even though the manufacturer may have filled that, it's still the weakest part of that log or lumber that's in there, so that pressure's going through and it'll start stretching that film over there.